Hey everyone, today we're going to be taking a look at how we can solve integrals in one of these 6 forms. Now, all of these equations or kind of theorems have been derived from u substitution, but I don't want to get into that. I just want to get into some integration problems and how we can use one of these 6 formulas to help us solve those. But for a quick lesson, let's actually go over them really quickly. We have integration 1 over x squared plus a squared dx equals 1 over a tan inverse x over a plus c. That should be a little bit familiar. I think number 1 and number 4 should be familiar because we're dealing with inverse trig functions. But for the other 4, I think memorization will come along when we do these problems. So we have integration of 1 over x squared minus a squared is equal to 1 over 2a log of something. We have a log over here, log here, log here. 2, 5, 3, 6. They're all something to do with logs. And we're going to test our knowledge in the upcoming examples right now. Alright, so on to our first problem. We have integration 1 over 4 plus 9x squared dx. And I'm going to go over the solution right now, so feel free to pause this video and give this problem a go. But for right now, I see that there is one main difference between this integral and the formulas we had before. And I'm just going to scroll up for 1 second to point out that difference. So whenever we take a look at x squared, we see that the coefficient of x squared is either -1 or 1. But in our problem over here, we see that the coefficient of x squared is 9. So we want to get rid of that 9 so we can actually apply these formulas over here. So in order to get rid of the 9, I am going to divide the top and bottom by 9. So if I divide the top by 9, that basically becomes 1/9 over 4/9 plus x squared dx. And this 1/9 is a constant. I'm going to take it out of the integral. Equals 1 over 9, integration of 1 over 4/9 plus x squared dx. And whenever we're dealing with problems like these where we have to apply one of these special integrals, I am going to change this into something squared. So 4/9 equals something squared. In other words, I'm going to change it to 1/9 integration of 1 over 2 over 3 squared plus x squared. And this way, this is actually in the form of one of our special integrals. This is the formula we will be applying. So we have 1 over a, which is going to be 1 over a. A is always the constant, so a is going to be that term right over there. So 1 over a is going to be 2/3. And then we have a tan inverse of x. X is going to be this. In a lot of the integrals, this x is not always just going to be x. It's probably going to be like x plus 2 or x minus 2/3. Either way, if it has an x connected to it, then that is our x that we're going to apply in this formula. But for right now, x is just x over here. So we have x over a. A we already established was 2/3, and of course our plus c. Now we just have to simplify it, so 3 over 2 tan inverse of 3x over 2 plus c, and that get canceled. We're left with 1/6 tan inverse 3x over 2 plus c. And that is our final answer. Now for our second problem, here we have integration of 1 over 16 minus 9x squared dx. Once again, we have the same exact problem. The coefficient of x squared is -9. It should be either be -1 or 1. So I'm going to divide top and bottom by 9. So we're going to have integration 1 over 9 over 16 over 9 minus x squared. So just divided top and bottom by 9 dx. Once again, 1/9 is a constant. I'm going to take that out. 1/9 integration 1 over 16 over 9 minus x squared dx. I'm going to rewrite this in terms of 16 over 9 equals something squared. In other words, we can write 1/9 integration 1 over 4 over 3 squared minus x squared. And we see that this is in the form of our third special integral, which is integration 1 over a squared minus x squared dx equals 1 over 2a log something plus c. So let's actually apply that straight away. We're going to take this over here equals 1/9, 1 over 2a, so 1 over 2a, once again, is going to be 4/3. 4/3, and then we have log of a plus x. A we already established is 4/3. X in this case is just going to be x over 4/3 minus x, 4/3 minus x, plus c. And all we have to do is simplify it. And this is our final answer. So here we have our third problem, integration 1 over square root 9 minus 25x squared dx. And in this case, it's going to be a little bit different because we have a square root in the problem now. But how I would approach it is that, once again, I see coefficient of x squared. It's not -1, it's not 1. So we need to do something with this integral so we can actually apply one of these special integrals, right? So in that case, we need to get rid of this 25. Now, many of you might be saying that divide both top and bottom by 25. And that would be a little bit flawed because we know that we want to divide just this part by 25. And that part is in the square root. So when you have something in the square root and we want to divide by 25, that's basically saying if you divide something by 25 in the square root, you have to divide everything outside the square root by 5. In other words, if we divide the thing in the square root by 25, we have to divide the thing outside the square root by 5. So let's see what that really means. We have integration. I'm going to divide both top and bottom by 5. So we have 1 over 5 over square root 9 over 25 minus x squared dx. Once again, 1/5 is a constant. I'm just going to take that out. We have 1/5 integration of 1 over square root. I'm going to rewrite 9 over 25 as something squared, and that is 3 over 5 squared minus x squared. And now we can apply the fourth special integral, which is integration 1 over square root a squared minus x squared dx equals sine inverse x over a plus c. So let's actually do that right now. We have 1/5, going to keep that outside. And in the big brackets, we're going to have sine inverse of x, which is just x over here, over a. A in this case is just 3/5, so 3 over 5 plus c. Let's simplify this. And that is our answer. So just a really quick point to note is that when you have something relating with square root, you need to remember the rules of square roots. If you want to get rid of this 25, then yeah, you could divide what's inside by 25, but you have to divide everything outside by 5. All right, fourth problem over here, integration 1 over square root a squared plus b squared x squared dx. Now, this might seem a little bit intimidating with the a and b, but I'll give you a hint. A and b are just constant. They can be like 4, they can be 9 as the problems we saw before, but they're just numbers. So once again, I don't want that b squared anywhere near x squared. So I'm going to divide both top and bottom by b. Once again, we have that square root, so we have to be a bit mindful of what we're going to divide by. So we have integration of 1 over b over, and since this is the square root, we're going to divide whatever's in the square root by b squared. So square root a squared divided by b squared plus x squared dx. Once again, if I divide what's inside by b squared, I have to divide what is outside by b. 1 over b is a constant, going to take that out. 1 over b integration 1 over square root. I can rewrite a squared over b squared as a plus b squared plus x squared. Now we're going to use our fifth special integral to solve this, which is integration 1 over square root a squared plus x squared, which is exactly in that form. Once again, a in this case is just a constant. Don't get that mixed up with the a in this part over here. Equals log of absolute value of something inside it plus c. So I'm going to take this over here as equal to 1 over b's. That's going to stay outside. Log of x. So x is going to be that, once again, plus square root of a. Once again, a is the constant. And the constant is this, a over b. So we have a over b, and that is squared over there, I see, plus x squared. X in our case is just x. Remember, it's not always going to be x, but in this case, it is x. So plus x squared, absolute value closed, plus c. Simplifying it further. So I'm going to take a pause over here. I applied the property of logs, which is log a over b is equal to log a minus log b. So in this case, I have that minus over here. I have that minus 1 over b log b, which is the bottom over here. Now this part is just a constant, right? Because b is a constant, and then log of absolute value of b is also going to be a constant. So all of this is just going to be a constant as well. So I can actually just replace all of that and just write plus c. And that is going to be our final answer. So for this problem, it's going to be a little bit different. We are going to apply our special integrals, but we actually have to apply something before we can do that. And that is long division. So we have integration x squared minus 1 over x squared plus 4 dx. And we know right off the bat that we can't apply any of our special formulas, because in order to do that, first off, we need integration 1 over something. And in this case, we don't have a 1 over something. We have an x squared minus 1. So in this case, let's actually apply long division. So we're going to have x squared plus 0x minus 1 divided by x squared plus 0x plus 4. So that is our long division. And now I'm going to rewrite this integral in terms of what we actually got over here. So that's going to be integration of this quotient 1, and that's going to be minus 5 over x squared plus 4. So this is quotient, remainder, divisor. And then, of course, we have our dx. And now you could see we have this integral right over here that we can apply our special integral formulas to. I'm going to break this integral apart into 2 parts so we can do that. So we have 1 dx minus integration of 5. Actually, I'm going to take that 5 out because it is a constant. 5 integration 1 over x squared plus 4 dx. All right. Now I know integration of 1 dx is just x, right? And in order to solve this, we're going to apply our first formula, this one right over here. So I'm going to have 1 over a. A in this case is going to be 2. Now the reason it is 2 because I could rewrite 4 as 2 squared dx. And we know a is going to be this a squared, and that matches up with 2 squared exactly. So we're going to have 1 over 2 tan inverse of x. X is just over here. So x over a once again is 2. And finally we have plus c. Let's simplify this a little bit more. X minus 5 over 2 tan inverse x over 2 plus c. And that is our final answer.